we're about to begin our first unit of the new school year. It's going to cover the real number system. Let's go ahead and get started on our first part. We have 5 different sections we're going to cover, and it's really not going to take long. And in front of you, you actually have the graphic organizer. And what I've also done is I'm going to put a digital copy just in case you lose it. And that way you'll have it re-download or reprint and redo if you need to. But otherwise, we'll come in tomorrow, bring it, and we can actually glue it into your notebook. So let's go ahead and get started on this. We've got our natural numbers. So if you'll notice, look, all 4 of these, we've got the natural, we've got whole, our integers, and rational, kind of all go together. But then if you look over here, you have your irrational. We're going to see how that goes together because these are all terms that we need to know. They're called subsets. They go together except for irrational. And the way I remember that is this. If you're being irrational about something, you can't be rational at the same time. So that's why you see irrational out here and rational and all the other ones over here. So our natural numbers, just you got to remember about those. They just start at 1 and they go up 1, 2, 3, 4, and so on, so on, so on. I'm going to put dot, dot, dot. There's no fractions. There's no decimals. There's no negatives in your natural numbers. So now, if I just progress on up to whole numbers, these are just like natural, except you add in 0. So I'm going to go 0, 1, 2, and 3, and dot, dot, dot. So that's the progression of that. Again, no decimals, no fractions. It just continues to go on up. The only difference was it added in 0 instead of just starting at 1. Now, if we go up to integers, that's our next. So integers, the only difference there is, well, now I can start with negatives. Say -2, -1, 0, 1, 2, and that is really messy, 2, and so on. Again, no decimals, no fractions. And if you look at this, before I go into rational, integers, whole numbers, integers, you're basically just progressing. You know, we started at 1 through your counting numbers, added in, 0, now we've just added in negatives. But then now, as we go up to rational, here's where we add in we can add in our decimals and fractions. But here's what we have to be careful with. With rational, integers, whole, and natural numbers are all rational. Well, a rational number is simply, you can have a fraction. For example, if I have 3/4, and it would help if you could actually see it better. So if I take 3/4 and I put it in fraction, it's 0.75. The thing about rational is you either have, if it's a decimal that terminates, for example, 0.75, or if I have, say, a repeating pattern. I'm not going to say just necessarily a repeating number, but a repeating pattern. For example, I have 0.333, and it just goes on and on and on forever, but it's the same repeating pattern of 3s. Or I could have, say, 0.75, 75, and it just continues on. The exact same pattern repeats over and over. That would be rational. So again, natural, whole, and integers all belong as rational numbers. And then you just add in fractions or decimals that are either repeating or terminating. That would be the term you need to remember about that. You know, if I have, now I'm going to throw something else in here for rational. If I have the square root of 81, well, if I take the square root of 81, that's going to give me 9. So if I wanted to know which one of these it fits in, well, 9 fits in natural, it fits in as a whole number, it fits in as an integer, and it fits in as a rational number. So all of those fit in. Now, what's the difference between all of these and an irrational number? What could possibly be left? The irrational number, it's going to be a decimal that it doesn't terminate and has no repeating pattern. For example, if I say 0.753126 and I just say ... there's no repeating pattern to this. It just goes on. And when you look at this, the ... that tells you, hey, wait a minute, it goes on. No pattern, and it goes on. It does not terminate. That's the difference where you have to be careful with rational and irrational. Now, the only thing I want to say about irrational, for example, if I have the square root of 3, well, if I take the square root of 3, I'm going to get this crazy decimal. It's going to be irrational. Here's something to remember, and this would be good in class. I may throw a question up about this. If it's not a perfect square, for example, 81 is a perfect square. Square root of 81, 9. Beautiful. Perfect, quick, easy. If it's not a perfect square, for example, I can't take a number, what I call pretty number, like 9, and just say the square root of 3. You're going to get this crazy decimal. If it's not a perfect square, it's going to be irrational. That's something to keep in mind that will help you forever and ever. If it's a perfect square, it's rational. If it's not a perfect square, when you're talking about square roots and radicals, it will be irrational. So what I want you to do, these are your notes, and this is, you have the organizer. If you need to watch this again, whatever you need to do, but I do want you to fill out your organizer. That will be something I look at in class. And I want you also to come up with one question. Everybody needs to come up with one question that we're going to discuss about this video in class tomorrow. And we will see you in class.